system substitution. Okay, substitution with systems of equations. We did this already when we originally did systems of equations. The difference this time is that these are not systems of linear equations. Okay, all sorts of different kinds of shapes are going to be made if we graphed these. Okay, so what we have to do is we have to use the substitution method by first solving one equation for y. First of all, does it always have to be for y? The directions say y, but does it always have to be y? No. We want to choose the variable that we think would be the easiest to solve for and the easiest to substitute into a different equation. Okay? Now, this x looks really easy to solve for. Divide both sides by y. This y looks really easy to solve for. Divide both sides by x. But what I want you to think about is when you plug it into the other equation, when you substitute it into the other equation, you're going to be substituting in a fraction. Is that always the easiest? No. In this case, this y would be the easiest to solve for because when we do that, we subtract 2x from both sides and we get y equals 11 minus 2x. When I substitute it into the other equation, we're not dealing with any fractions. Now, I'm not telling you that we can always get away with that. Sometimes we're going to end up having to solve for fractions and you're going to have to be okay with that. Okay? But for now, let's start here. I know that y equals 11 minus 2x. So I take that 11 minus 2x and I go to the other equation and put it right there for what y is. So I rewrite that equation, but I don't write y, I write what I know y equals. 11 minus 2x. Now that equals 14, doesn't it? Okay? Now this is just a simple Algebra 1 equation, isn't it? Okay, distribute our x here and here. I get 11x minus 2x squared equals 14. What kind of problem has this now become? It is a quadratic, so I need it to equal 0. If at all possible, you know me, I like to have my x squared term positive. So even though it's like one whole extra step, I'm going to move everything to the opposite side of the equal sign instead of just moving the 14. Yes, absolutely, you can just move the 14. But if you just move the 14, you have a negative x squared term. Does that make sense? So we end up with 2x squared minus 11x plus 14. We have some choices to make now. First of all, are all three of these numbers divisible by the same thing? Can I factor it to a lower equation? No, I can't. Okay? So what are my choices then? I can either factor or I can use a quadratic formula. Very good. Okay? What do you want to do here? You want to factor? We want to at least try to factor, right? So since I have a leading coefficient other than 1, I have to find my AC and I have to find my B, right? What is AC in this particular problem? God bless you. 28. And what is B in this problem? Negative 11. Okay? Can you think of two numbers that multiply to equal 28 and add to be negative 11? Negative 7 and negative 4. Okay? Remember, at this point we have to rewrite our problem. But we split our middle term to the two terms you just told me. Right? Split the middle terms to the two terms you just told me? Whoops, except I wrote 11 instead of 4. Sorry about that. Negative 7x and negative 4x, right? Okay. Now I factor by grouping. Just look at the first two terms. What do they have in common? X. If I factor out an x, what's left? 2x minus 7. Excellent. What do the second two terms have in common? A 2, right? But we want to factor out a negative 2 because we know what does this parentheses have to look like. It has to look like 2x minus 7. And from this to look like 2x minus 7, I have to factor out a negative 2. Are you remembering any of this? Yes. Okay, so then I have what I factored out of each term, and then I have what they had in common, the factor they had in common. All right? Now, for the record, I think it's ridiculous how much room they give us to work. We need a lot more room than this. Okay? Well, Sierra, you don't. I know that. I'm sorry. You probably have like 4 times as much room as you need, right? Yeah, see, I was right. Okay? So, if these are my 2 factors, what do I do with each of them? Set them equal to 0. I do not have enough room, so I'm going to give myself a little room to write x minus 2 equals 0, 2x minus 7 equals 0. So if I add 2 to both sides, I get x equals 2. Here I have to subtract 7 and then divide by 2. So I get negative 3.5. Okay so far? What does that tell me? What did I just solve for? For x. That's all I solved for, right? So that means if I graphed these 2 systems, what would be true about them? They would intersect twice at these 2 x values. 2 something and negative 3.5 something. What did I do? Tell me. Oh my goodness, thank you, Marilyn. We would absolutely add the 7, so that would just make that a positive 3.5. Thank you for catching that. I appreciate that. Good job, Marilyn. See, when I get too excited about the math, sometimes I mess up. Okay? Okay. But guess what? I'm a human. You guys mess up too, right? Because you're humans. We are not robots. No, we're not. Okay? So, but it's good that we're catching each other's mistakes though, right? That's very good. That's very good. Okay, so how am I going to get the y values? Plug it into the simplest equation. And is that personal preference? It is, right? So go back up to the original 2 equations. Which one, in your opinion, is the simplest to use? You want to use the first one? Okay. So xy equals 14. I know x is 2. So 2y equals 14. How do I solve for y? Divide by 2. Y equals 7. So when x is 2, y is 7. Then I have to do this all again, don't I? Well, not all of it. Not all this stuff, but this thing over here, right? xy equals 14. This time x equals 3.5. 3.5y equals 14. Again, I had to divide both sides by the multiplier, which in this case is 3.5. Y is 4? Exactly 4? Yes. So when x is 3.5, y is 4. So now you can be very specific and tell me what would happen if you graphed these 2 equations. They would intersect at the points 2, 7 and 3.54. Perfect. Okay? Relatively simple. Could you follow all my steps? Could you recreate those steps on your own? Okay, then let's do number 2. It's already been very clear that I'm not going to have enough room to write, so I'm just going to start this problem on my notebook paper. Okay? If you want to do the same thing, please do it. But please keep in mind, I do expect you writing this down. I'm not doing this for me. I already know how to do it. Okay? So I have 2 equations. In your opinion, which variable would be easiest to solve for in this problem? I hear y on the first equation. So which one do you think I would solve for? Y on the first equation. Very good. Okay? Now, I keep saying in your opinion. Is there really a right answer or a wrong answer here? No, there's not really a right or wrong answer. There's like one that would probably be easier than others. Okay? So I'm trying to help you form your opinions in a very educated manner. Is that fair enough? Good. Okay? So in order to solve for y in this case, I'm going to add x to both sides. So I'm going to get y equals x plus 8. Now, can I show you what I did? And I did it on purpose. I promise I did. The first time we solved for y, how did I write it? 11 minus 2x. How did I write it this time? X plus 8. Is there a correct form we're trying to get this in right now? Yeah, there's not, is there? We're not trying to get like slope-intercept form or something like that. We just want it all on the same side. I did this on purpose so that you could see that it doesn't matter. Fair enough? Okay, what do I do with what I know now? So I have to go to the other equation, which is the second one up here, x squared plus y squared equals 34. And I have to rewrite that equation, x squared plus, but I don't want to write y squared because I know what y is, don't I? Y is x plus 8 squared equals 34. Okay? Now, what does it mean to have x plus 8 squared? What does that mean? Okay, so I could actually rewrite it like this. X plus 8 times x plus 8. In fact, that helps us a lot, doesn't it? Because we remember to distribute. We don't just try to square the first and square the second, which will just get us the wrong answer. Okay? So I have x squared plus x squared plus 8x plus 8x plus 64 equals 34. Okay, so you're telling me to combine like terms? Those two and then these two? So x squared plus 16x plus 64, 2x squared, thank you, equals 34. What type of function is this? A quadratic, so I need it to equal 0, so let's subtract 34 from both sides. 2x squared plus 16x plus 30 equals 0. What can I do? Oh, you would try to factor it? How? Would you do that first? Would you find AC first? We divide everything by 2, right? Here and here. If we do both sides by 2, then we don't have to worry about it anymore, do we? Okay, so if I divide every term by 2, I get x squared, God bless you, plus 8x plus 15 equals 0. Oh my gosh, how much simpler did this problem just become? A lot. Can you tell me the factors right now? Oh my goodness, x plus 5, x plus 3 equals 0. It wouldn't be different factors if we try to factor it up here. This one would probably look like 2x plus 10. Or this one might look like 2x plus 6, depending on how we did it. But it would still end up being the same thing. That's a good question, though. So from here, I have to set each of these factors equal to 0. Yes. Wait. What? Don't. If you need this step right here, I'm writing this step right here for people that need it. If you can go from here to here, that's totally fine with me. Fair enough? Okay. There's just still some people who need to see this. It's not that they're dumb. It's not that they can't even skip steps. It's that they need to visually see what's happening. Like, I'm even skipping a step in here, aren't I? I'm not writing minus 5 or minus 3 minus 3. Okay? So, what do my answers look like? Do I know yet? I know I'm halfway, right? One of my answers looks like negative 5 something, and one of my answers looks like negative 3 something. Okay? So how do I figure out those somethings? Okay, like this first equation you'd plug them in? Yeah, this is the equation we should plug them in, right? Because it's equivalent to that, isn't it? But y is already solved for. So when I plug the number in, I'm going to figure out what it is. Y equals x plus 8 is my equation. Okay? So y equals, let's do the first one first, negative 5 plus 8. What is negative 5 plus 8? 3. So when x equals negative 5, y equals 3. And then we have y equals negative 3 plus 8. So y equals, when x equals negative 3, y equals 5. Tell me what these answers mean. If I graphed these two functions, they would cross at these 2 points. Very, very good. Okay? Questions? Are you getting the general idea? Okay, I want you to look at 3, 4, 5, and 6. I want to do one more. Which one would you like me to do? I'm hearing mostly 4s. Is 4 okay with everyone? So, which variable should I solve for? Keep in mind that I've got an x squared here and an x squared and an x. So it's probably not a good idea to try to solve for x's. So you say 3y on the second one. Can you tell me why you say 3y on the second one? It's already a positive. That's probably a good choice. Okay? So I'm going to write this down again so I have it written down. 3y minus 5x squared plus 12x equals 3. And I'm solving for this y variable. Okay? This is number 4, correct? Okay. So in order to solve for y, I have to get these two things on the other side of the equal sign first, don't I? So I'm going to add 5x squared, and I'm going to subtract 12x. You guys are checking my signs, right? You know how great I am at signs. So I have 5x squared minus 12x plus 3. You all right so far? Okay. So next I need to divide everything by 3. Y equals 5 over 3x squared minus 4x plus 1. Now, guys, is that really ugly? It's just a quadratic, isn't it? Just a parabola? Is it uglier than the ones we've done? Yes. Okay. So now I need to go back to the other problem, the other equation that I was given. Okay? 4x squared minus 6x minus 2, but I don't want to write y, do I? I want to write what I know y equals right there. So 5/3 x squared minus 4x plus 1, and that all equals 10. So what I want you to keep in mind right now is this. Is this hard? It is not hard, it is tedious and time consuming. Okay, which is why I only gave you 6. Fair enough? Okay, so now we need to just start simplifying this. 4x squared minus 6x. What's happening to this negative 2? To each term, right? Distributed to each of these terms. So I have negative 2 times 5/3. That gives me negative 10/3 x squared. Negative 2 times negative 4x is plus 8x. Negative 2 times 1 is negative 2. Okay? Now, combine like terms, right? Okay, my x squared term has a fraction. It's a fraction with a denominator of 3. Can I change this to be something with a denominator of 3? Isn't that 12/3? Isn't this the same as 12/3? So what is 12/3 minus 10/3? 2/3 x squared. Then I have negative 6x and a positive 8x. So plus 2x. And then minus 2 equals 10. So I need it to equal 0. So let's subtract 10 from both sides. 2/3 x squared plus 2x minus 12 equals 0. You ready for a secret? Can I get rid of this fraction? How? How can I get rid of it? You know how, like on this problem right here, we divided everything by the same number? Are you allowed to multiply everything by the same number? What would help us here? Not necessarily the reciprocal. That's not going to help me all the time. But what if I just multiplied by the denominator? What if I multiplied every part of this problem by 3? Now, for the record, I'm doing this so I could try to factor. Could I, from right here, do the quadratic formula? Absolutely. Okay? But I know that sometimes factoring can be easier, so I'm going to try that first. Okay? If I multiplied everything by 3, what is 2/3 times 3? I'll tell you in a minute. I'll tell you in a minute. What is 2/3, what is 3 times 2? 6x. What is 3 times negative 12? Negative 36. So the reason I want to start with just the denominator, I am in total agreement with you that we could have multiplied this particular problem by the reciprocal. Fair enough? But I'm trying to make sure that we know what to do with every problem. Okay? We start with just the denominator, because what if these numbers were not divisible by 2? All that would do is give us more fractions, wouldn't it? Okay? Now, can I divide everything by 2? Yeah, in this particular problem I can. It does not work like that on every problem, so just take it a little bit at a time. Okay? When I divide everything by 2, what do I end up with? Because it was positive 8 and negative 6, which gives me positive 2, and then when I multiplied everything... No, that's okay. I did the same thing a minute ago. Is this something I can factor? So tell me, what two numbers multiply to be negative 18 and add to be positive 3? X plus 6, x minus 3. Did I lose anybody? So x equals negative 6 and x equals positive 3. Did I skip too many steps for too many people? Remember, we do x plus 6 equals 0 and x minus 3 equals 0. So I know at the end of the page somewhere I'm going to have two answers that start like this. Will I always have two answers? Not necessarily, right? I didn't when I did systems of linear equations, because they can only cross one time, can't they? Okay. So now what? Where should I go back? Thank you. Yeah, how about right here, right? Y is already solved for in this particular function right here, so why don't we go back right there? So we say y equals 5/3 times negative 6 squared minus 4 times negative 6 plus 1. Well, negative 6 squared is 36, so that gives us 5/3 times 36 plus 24 plus 1. So I need 5/3 times 36. 60. So 60 plus 24 plus 1. That's 85. It must be wrong because it's too big. Wait, so I can get an answer like negative 6, comma 85? There's really a point on the coordinate plane like that? Yeah, don't freak out automatically because it's a bigger number than you expect. Okay? especially when you're pretty sure you did everything wrong. Right, you can always go back and check, can't you? Okay, good. So now I have to do it again, but this time with 3. So 5/3 times 3 squared minus 4 times 3 plus 1. And look, we're doing it the hard way, aren't we? We're doing it the way we would do it if we didn't have a calculator. Remember, we have a calculator, and we can actually do, not that, 5/3 times 3 squared minus 4 times 3 plus 1. Oh look, it's 4. Should I ever get any of these wrong? Why not? Shouldn't I plug them back in? I really should. Okay? We can do that very easily and simply in the calculator. Just substitute x and y in for both the original problems. Make sure they equal what they're supposed to equal. It doesn't even take a long time, does it? Yeah, that's what I'm saying. Yeah, plug it back into the original equations. Alright? Questions? Okay, so we have 3 left to do. 3 left to do. It is Thursday, right before Good Friday, so I do hope you have an excellent weekend. Kingston out.